Hello, hi everyone. Welcome to the Student the Brand. This is your Shiva sir. Today we are going to discuss about electric current, CBSE Grade 10 Physics. Electric current, CBSE Grade 10 Physics. Electric current, CBSE Grade 10. CBSE Grade 10 Physics. Okay. I equal to Q by T. I equal to Q by T. The rate of flow of charge. The rate of flow of charge is called electric current. Rate of flow of charge is called electric current. Okay. So rate of flow of charge. Rate of flow of charge is called electric current. Okay. I equal to Q by T. I equal to Q by T. So SI unit of current is ampere. SI unit of charge is coulomb. SI unit of current is ampere. SI unit of charge is coulomb. SI unit of time is SI unit of time is second. SI unit of current is ampere. SI unit of charge is coulomb. SI unit of time is second. Right? I equal to Q by T. Rate of flow of charge. Rate of flow of charge is called electric current. 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second. 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second. That is called I equal to Q by T. SI unit of current is ampere. SI unit of charge is coulomb. SI unit of time is second. SI unit of time is second. Okay. Now, charge you can take. Charge is moving inside of the conductor. Charge is moving inside of the conductor. Yes or no? So if the 1 electron, 2 electrons, if only 3 electrons, only 1 coulomb, 2 coulomb. So inside of the conductor only 1 electron, if it is flows, we can't say current is flowing. Only 2 electrons flows also we can't say. Only 1 positive charge will move also we can't say. Right? So if number of charges are moving inside of the conductor, okay, then only we can able to say current is flowing. Current is flowing, right? So positive charge, negative charge, positive charge, negative charge, positive charge, negative charge, positive charge, negative charge. Like that, charges are moving inside of the conductor. Charges are moving inside of the conductor. That is quantization of charge. Q equal to plus or minus Ne. Q equal to plus or minus Ne. Okay. So Q equal to plus or minus Ne I am taking. Yes or no? Now N is the number of charges. Number of charges are moving inside of the conductor. Number of charges. So that is nothing but electrons we can say. So positive charges are there, negative charges are there. Positive charges are moving, negative charges are moving. Okay. So charges are moving inside of the conductor. Charges are moving inside of the conductor. That's why N I'm taking. Q equal to plus or minus Ne. Q equal to plus or minus Ne. On one electron, how much charge is present? On one electron, if you are taking on one electron, 1.6 into 10 power minus 19 coulomb. In 1 coulomb, how many electrons are present? In 1 coulomb, how many electrons are present? We'll discuss now. That is, in 1 coulomb, 1 by 1.6 into 10 power minus 19. And that is 1 by 1.6 into 10 power 19. Then 1 by 1.6 into 10 by 10. Then you'll get 10 power 19. Then 10 by 16 into 10 power 19. Then you'll get 10 by 16 is 10 by 16 is, so 10 by 16 you'll get 0.625. 0.625 into 10 power 19. That is 1 coulomb. 6.25 into 10 power 18 electrons are present. Okay. So these 2 points are very, very important. These 2 points are very, very important. Yes or no? So once again, listen carefully here. Listen carefully. Observe carefully here. So 1 amp I equal to Q by T. SI unit of current is ampere. SI unit of Q charge is coulomb. SI unit of time is second. Okay. So 1 ampere equal to 1 coulomb per 1 second. 1 ampere equal to 1 coulomb per 1 second. Right. Now, so charges are moving inside of the conductor. Charges are moving inside of the conductor. Charges I am taking. So Q equal to plus or minus Ne. N is the number of charges. Number of charges. If it is positive, positive. If it is negative, negative. Okay. So positive charges are moving inside of the conductor. If you are taking plus, negative charges are moving. So negative charges, positive charges are there, negative charges are there. So Q equal to plus or minus Ne. This is called quantization of charge. Quantization of charge. Okay. Q equal to plus or minus Ne. So on a 1 electron, 1.6 into 10 power minus 19 coulomb. In 1 coulomb, so 6.25 into 10 power 18 electrons are present. Okay. So I hope it is very clear. Next one. So we'll discuss about electrical appliances. Now, so I'm taking here. First one is cell. Second one is battery. Third one is switch. Fourth one is closed switch. Fifth one is resistor. Sixth one is rheostat. So resistor, rheostat will discuss. As as rate of flow of charge is called electric current. As as the rate of flow of charge I equal to Q by T, that is called electric current. Electric current. So here I am taking, this is the rheostat or okay, here you can see cell, battery, open switch, closed switch, resistor, rheostat, here ammeter, voltmeter, ammeter, voltmeter, bulb, wire joining, wire crossing. Wire joining, wire crossing. So now you can observe here. Now you can observe cell, battery, open switch, closed switch, resistor. Resistor is a device which is used to oppose the electric current. Resistor is a device which is used to oppose the electric current in the circuit. Resistance is the phenomena of opposing the electric current in the circuit. Resistor is a device. Once again, listen carefully. Resistor is a device which is used to. Resistor is a device. Okay. Resistor is a device which is used to oppose electric current in the circuit. Resistor is a device. Here rheostat. Rheostat is a device. Rheostat. So rheostat is a device which is used to regulate the current, regulate the current, regulate the current without changing the voltage source. Regulate the current without changing the voltage source. Is it clear or not? Once again, rheostat is a device which is used to regulate the current without changing the voltage source. Ammeter is a device which is used to Ammeter is a device which is used to measure the electric current. Ammeter is a device which is used to measure the electric current in the circuit. Okay. So ammeter is connected in series combination. Ammeter is connected in series combination. Coming to the voltmeter. Voltmeter is a device which is used to measure the potential difference. Voltmeter is a device which is used to measure the potential difference. Voltmeter is connected in parallel combination to the circuit. Voltmeter is connected in parallel combination to the circuit. Okay, bulb. So wire joining, wire crossing. So these are electrical appliances. These are all electrical appliances. Now I will discuss one more, that is okay. Now we will discuss about electric circuit. Electric circuit. Electric circuit is nothing but a continuous and closed path of an electric current. A continuous and closed path of an electric current is known as an electric circuit. A continuous and closed path of an electric current is known as an electric circuit. Okay, electric circuit. Now you can see here electric circuit. So I am taking this cell, switch, current is flowing. Okay, here you can see current is flowing. Current is flowing. Yes or no? A continuous and closed path of an electric current. A continuous and closed path of an electric current is known as an closed path of an electric current is known as an electric circuit. Current is flowing like this. Here, one is conventional current, another one is electric current. One is conventional current, and the second one is electric current. Electric current. So kindly do like, share, and subscribe to Student Brand. So thank you so much, everyone. Those who are supporting me and so listening to the class. So I am not doing anything, just I am taking class, right? So just concentrate here. Conventional current is nothing but so the flow of positive charges, positive charges are moving from positive terminal to negative terminal. So positive charges are we can take proton. So I'm taking positive charges, whereas electrons are negative charge. So positive charges will move always from positive terminal to negative terminal, whereas electrons will move from negative terminal to positive terminal. And one more thing here, one more point is there. Positive charges are moving from high potential to low potential. Positive charges are moving from high potential to low potential, whereas electrons are moving from low potential to high potential. Once again, positive charges are moving from high potential to low potential, whereas negative charges are moving from low potential to high potential. Positive charges, high potential to low potential, negative charges, low potential to high potential. Conventional current is nothing but the flow of positive charges. The flow of positive charges is known as conventional current. The flow of positive charges is known as conventional current. Electric current is nothing but the flow of electrons. The flow of electrons is known as electric current. Conventional current is nothing but the flow of positive charges. Electric current is nothing but flow of electrons. So positive charges will move from high potential to low potential, whereas electrons will move from low potential to high potential. So this is about conventional current and electric current. Conventional current and electric current. Next, so we'll discuss about one more, that is potential difference and electrical potential. Potential difference and electrical potential. Potential difference and electrical potential. So what is potential difference? Potential difference is nothing but work done to bring unit positive charge from one point to another point. Work done to bring unit positive charge from one point to another point within the conductor is called potential difference. Potential difference. Potential difference. Potential difference is nothing but work done to bring unit positive charge from one point to another point. So I am taking here. So this is one point, point A, and this is one point, point B. So positive charge is there. We are doing some work. Okay. We are doing some work to bring okay. So experiment I will do. So not now, Ayush. So now it is not possible. So in future I'll try to do. So I'll explain with the help of activity. So we'll see. Okay. Now potential difference. Potential difference is nothing but work done to bring unit positive charge from one point to another point within the conductor is called potential difference. So actually it is a part of the teaching. So you can check my videos. So go and check the videos. So those who are new to the channel, so please do like, share, and subscribe to Student the Brand. So Student the Brand. So please do like, share, and subscribe to Student the Brand. You can see. So this is Student the Brand, right? So that's enough. So just check once go and watch my videos. Watch the YouTube channel, then you'll get to know. Okay, so we'll start the class. Potential difference is nothing but work done to bring unit positive charge from one point to another point within the conductor. Work done to bring unit positive charge from one point to another point within the conductor is called potential difference. Okay, so 1 volt V equal to W by Q. V equal to W by Q. So work we are doing some work to bring unit positive charge from one point to another point. Okay, so that's enough. Next one. Now 1 volt equal to 1 joule by 1 coulomb. 1 volt is equal to 1 volt equal to 1 joule by 1 coulomb. 1 volt of work is 1 volt is defined as 1 joule of work is done to bring 1 coulomb of charge from one point to another point. Once again, 1 volt is defined as 1 joule of work is done to bring 1 coulomb of charge from one point to another point within the conductor is called potential difference. Coming to electrical potential, electrical potential. Electrical potential is nothing but work done to bring unit positive charge from infinity to the required field. So I'm taking this the positive charge from infinity. This is the required field. Suppose you take it is the required field. So we are doing some work. So W, we are doing some work to bring unit positive charge from from infinity to the required field. From infinity to the required field. Work done to bring unit positive charge from infinity to the required field is called electrical potential. Electrical potential. Once again, potential difference is nothing but work done to bring unit positive charge from one point to another point within the conductor is called potential difference. Electrical potential is nothing but work done to bring unit positive charge from infinity to the required field. From infinity to the required field is called electrical potential. Is called electrical potential. I hope it is very clear. So potential difference and electrical potential. Now, so we will discuss about Ohm's law. Ohm's law. Okay. Now we will discuss about Ohm's law. Okay, so now I'll discuss about Ohm's law. Ohm's law is nothing but Ohm's law is nothing but the potential difference. The potential difference across the ends of the given metallic conductor. The potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it. V is directly proportional to I. V is directly proportional to I. V equal to IR. V is directly proportional to I. V equal to IR. Okay. So materials required. What are the materials required to do the activity? Materials required. First one, 4 cells. 4 cells you have to take. 4 cells. 4 cells, 1.5 volts each. Second one, nichrome wire. Nichrome wire is an Li of nichrome wire 0.5 meter length. And coming to the third one, nichrome wire. Next one, nichrome wire and ammeter. Ammeter. Fourth one, voltmeter. Voltmeter. And fifth one, ammeter, voltmeter, switch, and connecting wires. Okay, connecting wires. Materials required 4 cells, 1.5 volts each. Nichrome wire is an alloy of nickel, chromium, manganese, and iron metals. Ammeter, voltmeter, switch, and connecting wires. Connecting wires. Okay. So these are the materials required. Materials required. Next one. So we'll discuss about procedure. procedure to do this activity. One is, first you have to connect one cell. First you have to connect one cell and note down the reading of ammeter and voltmeter. Connect one cell. Connect one cell and note down the reading of ammeter and voltmeter. Next, connect two cells. Two cells. Connect two cells and note down the reading of ammeter and voltmeter again. Repeat the process for 3 and 4. Repeat the process for 3 and 4. Repeat the process for 3 and 4. Okay. So serial number of cells, current, voltmeter V by I equal to R. So 1, 2, 3, 4. Okay, 4 cells. 4 cells. So number of cells 1, 2, 3, 4. Procedure, what is the process? First you have to connect one cell and note down the reading of ammeter and voltmeter. Connect two cells. Again, note down the reading of ammeter and voltmeter readings, that is I and V. Ammeter reading is current. Voltmeter reading is potential difference. Mention in the tabular form. Mention in the tabular form. Okay. Once again, first connect one cell and note down the reading of ammeter and voltmeter mentioned in the tabular form given below. Next again, connect two cells. Connect two cells. Connect two cells and note down the reading of ammeter and voltmeter and repeat the process for 3 and 4. Repeat the process for 3 and 4. So after measuring the values of ammeter and voltmeter, and you mention in the tabular form here. Okay, so in the given below. Now, if you draw the graph for V and I, if you draw the graph for V and I, the graph is linear. The graph is linear for ohmic conductors. The graph is linear for ohmic conductors. For ohmic conductors. Okay. Ohmic conductors. Ohmic conductors. The graph is curved for non-ohmic conductors. Okay. For ohmic conductor, the graph is linear. For non-ohmic conductor, the graph is curved. For non-ohmic conductors. Non-ohmic conductors. Sir, what is the meaning of ohmic conductors and non-ohmic conductors? Ohmic conductors means the substances which obey Ohm's law. The substances which obey Ohm's law, those are called ohmic conductors. The substances which does not obey Ohm's law, those are called non-ohmic conductors. The substances which obey Ohm's law, those are called ohmic conductors. The substances which does not obey Ohm's law, those are called non-ohmic conductors. Okay, so this is about Ohm's law. I hope it is very clear. Ohm's law gives the definition of resistance. Ohm's law gives the definition of resistance. So resistance depends on length of the conductor. Resistance depends on area of the cross section. Now you can see here. Now we will discuss about resistance and resistivity.